Welcome to lecture number 5 of Computer Programming 2. At this point, we have created our vehicles project with a user interface class called driver and a noun class called car. And we're going to extend this now, and we're going to make something that looks like the class diagram here. We're going to make a neon, which is a basic car. We're going to make a Cavalier, which is a basic car plus one additional piece of data, which is whether or not it's a convertible. And then we're going to make a Prius, which is a fairly complicated car. Okay, so again, the analogy to your programming assignment, driver is banker, car is account, neon is savings, Cavalier is certificate of deposit, and Prius is checking. So, first of all, how do we set up this is a relationship that we keep talking about? So we know this open arrow pointing up, open arrowhead with a solid line indicates a neon is a car. And we know that a neon can inherit any non-private attributes and methods of car. Okay, so how do we set this up? It's actually fairly simple. I'll bring my NetBeans over here. Right-click on Vehicles, choose New in Java class. Okay, and in this class, I'm going to call this Neon. Okay, all the rest is fine. And choose Finish. Now, what I can say here, I'll bring the editor back over, is simply Neon extends car. Remember, a Neon is a very basic car, just like a savings account is a very basic account. Okay, so I'll put some documentation here. A neon is a basic representation of a car. Okay, believe it or not, at this point we're basically done with neon. As a matter of fact, your savings class should look very similar to this, and that's it. So public class neon extends car. That means that we automatically get all of the non-private attributes and methods from car. So if I wanted to say, for some reason, I'm going to erase this in just a minute. If I want to make a dummy method, public void foo, okay, and in this method I want to access an attribute from the superclass car, like odometer. Odometer equals odometer plus 100. I can, and notice that this is not redlining. Not only is it not redlining, but the attribute name is showing up in green, indicating that it is an attribute. So this word extends. What this means is we put the child class or the subclass to the left, and then the superclass or the parent class to the right. And that sets up the is a relationship between neon and car. Because there are no special attributes, we can just leave it like so. And now take a look. If I go back to driver, instead of car my car equals new car, I can say neon my car equals new neon, and the program still works. And I can go ahead and run, and we'll give it a second for the J option pane to pop up. But this will run just as it did before. And what's interesting is that instead of using the data type car, we're now using the data type neon. So it's compiling now. We'll give it just a moment. There we go. What's the odometer reading? 10,000. How many gallons of gas? 10. Miles per gallon? 25. Anything else to enter? No. And there we go. Same output as before. Of course, I only did one car this time. But beyond that, the same output as before. So extending a class and just inheriting behavior is quite simple. It's so simple that usually when we extend a class, we're doing it for a good reason. So let me come back now, and instead of neon, I'm going to make another new car. I'll say new Java class. This one will make our Cavalier. Okay, Cavalier. Okay, I miss the Cavalier. I miss the 90s, to be honest with you, but I miss the Cavalier. Public class Cavalier extends car. Again, we set that is a relationship up. Now, for anything that we want to keep specific to the Cavalier and not general to a car, in other words, something that only applies to a Cavalier, not a Neon, not a Prius, we'll put it in this class. So we'll say public, let's say private Boolean. Remember, Boolean is a yes or a no. Convertible. Okay, and then I'll right click and choose refactor. And I know this is off screen just a bit. Refactor encapsulate fields. Um, that works. One slight difference. Remember, a Boolean is a true or a false. We still have a setter method, but the getter method actually starts with the word is instead of get. That specifically indicates that it's a Boolean, because is convertible will return true or false. Okay, and I choose refactor. And there we go. Okay, now I save this, and let's go back to driver. And I'm going to say Cavalier, my car, equals new Cavalier. Okay, now if I want, I can say my car dot set convertible false, like so. Notice I can invoke this set convertible method, save, and run. Why can I do this? Because the variable is of type Cavalier and the object is of type Cavalier. So I'll go ahead and run. Okay, we'll give this a moment. What's the odometer reading? 10,000. How many gallons of gas? 10. Miles per gallon? 25. Do you want to enter more cars? No. And once again, we see the exact same output we saw before, because Cavalier and Neon are both extending from car. One trick though, what if we change this back to Neon? At that point, we can no longer invoke set convertible because that's specific to Cavalier. So I'm going to remove this. Okay? So I'm going to remove that. We now have Neon and Cavalier, and we will set up a Prius as well. Okay? So I'll save, and then I'm going to go back and choose Vehicle, right-click New, Java Class, and we'll say Prius. Okay? You see, this goes, honestly, very quickly. So don't be intimidated on programming assignment 2 by the number of classes you have to do, because it all comes together pretty quickly. So Prius, we had int miles per milliamp hour, which is how many miles do we get out of a battery charge, and int battery level. We'll say battery level if we want. Okay, right-click, refactor, and then encapsulate fields, and refactor. And there we go. Okay. We might want to give some defaults here because let's give these some defaults. Miles per milliamp hour equals, let's say, 10 miles per milliamp hour. That seems like a lot, but okay. Battery level equals 100. How about that? Let's say battery. Let's make them both 10. There we go. And save. Okay. Go back to driver. And Prius, my Prius, of course you've seen this before. Or let's keep it my car. Equals new Prius. Okay, and save. Oh, you know what? I forgot to do Prius extends car. There we go. And save. Back to driver again. And that's why I was getting red lines there. Okay, let's run this one more time. Oh, phooey. Okay, what don't you like? I think, okay, just had to catch up. So we'll run this one more time. Again, we'll give it a few moments for the prompt to come up. What's the odometer? We've seen this before. 10,000. How many gallons of gas? 10. How many miles per gallon? 25. Do you want to enter more cars? No. And once again, we get the same output that we've seen before. Now, we have something going on here where we keep having to hard code what we're creating. It would be nicer if we could give the user a choice and say, what kind of car do you wish to create? Okay, we need to think about how to do that though. We need to think about that. How can we give the user a drop-down box that says, what kind of car do you want to create? Okay? All right, what we need here is a factory method. Okay, what we need here is a factory method. So instead of hard coding Prius my car equals new Prius, I'm going to make what's called a factory method. Factory method is a design pattern. A design pattern is a programming technique that's used over and over again. The only trick is we have some unanswered questions. So we're going to have to leave a few things blank and deal with a couple of red lines until we answer these questions. So what I'm going to do is say, we'll go ahead and make this public. Public, one of the unknowns is what's our return type. For the moment, I'm going to make it void, but we're going to have to change that. Public void create car. Okay, string car type. Okay, open curly, close curly. Now we'll do an if test. If car type dot equals ignore case Cavalier. Okay. Then we'll say, okay, I'll tell you what I'll do. I'm going to make this an object. Public, no, let's not, because I don't like that word. That's going to confuse things. I'll just put a comment here that says create and return a new Cavalier. Okay. Else if car type equals ignore case neon, create and return a neon. Okay. Else if car type equals ignore case Prius. Okay. Create and return a Prius. It's easy enough to do that create and return. All we have to do is say return new Cavalier. Okay, now here we say return new neon. And finally here, return new Prius. So notice in each of these cases, we're invoking a constructor and returning the object that's created from that constructor. But here's where the trick comes in. What should our return type be? Because remember, if we have a return statement, that means that our method has to have a return in its signature as well. It can't just be void. If I make it Cavalier, then this return new Cavalier, the red line goes away. If I make it neon, then the neon goes away. The neon red line goes away. If I make it Prius, then the Prius red line goes away. So I can't choose any of those because it will make one work and the other two not work. Okay? So what you need to think now is what return type will make all three of these lines that currently have red lines, the return new Cavalier, return new neon, and return new Prius, what will make them all compile? What can a return type be that will make those all compile? And think about that for a second. Literally, think about it for a second, because I'm going to pause for a few moments and let you think about that question, which is, what return type can I give to this method that will remove all the red lines? Well, we have to think about what they all have in common. And let's take a look. We know that a Prius, a Cavalier, and a neon are all a car. A Prius, a Cavalier, and a neon are all a car. This is one of the nice advantages of having a superclass, is that we can have an object of the subclass type, and the variable can be the superclass type. So, public car, create car, string car type, and there we go. We have a red line here, but we can take care of it pretty easily. Now that we have that, it actually makes life pretty easy, because remember I said you really shouldn't have a return line unless it's the last line of the method. Now that we've decided what our return type can be, I can clean this method up a bit. I can say car, return car, okay, and I'll say here, declare the return variable. And then here I can say return car equals new Cavalier. Down here, return car equals new neon. And finally here, return car equals new Prius. And now the last line, return car. Okay. For this, I need to assign it to something. I'm simply going to assign it to null to get rid of that red line. Notice now the method works. And so let me explain what's going on. We're declaring the variable, and we're assigning the variable. in two different places. We're declaring the variable here on line 79. We're returning that declared variable on line 90. The lines in between those two are assigning an object into that variable, depending on the user's selection. And because we have an if, else if, this if test is mutually exclusive. Only one of these can run, the other two will not. Okay? Depending on what the user enters, only one of these will run, the other two will not. But what's interesting to see here is that the variable is declared here and initialized with an object either here, or here, or here. But the object type is different. The object type is the subclass of car. So, we can have a variable and give that variable the superclass type. And then the object can be either the same type or a subclass of that type. In other words, I'm going to erase this line in just one moment. Car, your car equals new neon. That's valid. Car, your two car equals new car. That's valid. Same type. Car, your three car equals new Prius. That's valid. Car, your four car equals new Cavalier. Each of these are valid. The object type is what we're declaring by calling a constructor on the right. The variable type is the type of the variable on the left. The variable type can be the same as the object type, or the object type can be a subclass of the variable type, like so. We can't go the other way, though. We can't go the other way. In other words, we can't say neon, my neon equals new car, or more specifically, Cavalier, my Cavalier equals new car. We cannot do that because the variable type tells us what methods we're allowed to call. The object type tells us what behavior we'll get when we call those methods. So if we declare a variable of type Cavalier, because the variable type will tell us what methods we're allowed to call, it says we're allowed to call the method set convertible and is convertible. But the object type is over here. Car is more general than a Cavalier. There's no guarantee that the car is actually going to have those methods. So variable type tells you what methods you're allowed to call. Object type tells you what behavior you'll get when you call that method. Variable type can be the same as the object type, or variable type can be a superclass of the object type. But variable type cannot be a subclass of the object type. Okay? That part's really confusing. If it is, you might want to rewind and replay that last 5 minutes or so. Because this is a concept, we're going to see a lot of quiz questions on it, and we're going to see a lot of exam questions on it. Now, I need to do some housekeeping. Let me clean this up. Okay. A factory method, method to create cars. Factory method, that's a design pattern that's very well known in programming. If you tell somebody factory method, they typically know it's going to have syntax like this. Accept some indication of what kind of object to return, create the object, and return it as a superclass variable type. That's what factory method means. It's a very commonly used pattern. It's something that most experienced programmers will know about. Parameter car type, an indication of what type of car to create and return. Okay, return the created car object as a superclass car type. All right, looks good to me. And save. Now, we haven't called this method yet because it wasn't complete. At this point, the method is complete. And what we can do now is go back upstairs, and instead of Prius my car equals new Prius, we can say car my car equals create car Prius. Okay, of course, we've still hard-coded the string, so what we'll probably do, what doesn't it like here? Oh, I need to add static to that method signature. Public static car create car. Okay, so what we'll need to do then is we'll need to prompt the user, and we could either have them enter an empty string, or we can do one of these tricks with the JOption pane where we give it a predefined array. I like the predefined array thing better, so we'll say string all cars, let's say, no, string car choices equals new string, and we'll say we're going to put 3 elements in there. Okay, car choices 0, because remember our element will start counting at 0. 0 equals neon. Car choices 1 equals Cavalier. Car choices 2 equals Prius. Okay, now we need that special JOption pane method. This is going to be a long one, so let me scroll over and try and maximize what I can fit on the screen. JOption pane dot show, I want to say input dialog. Yes, this one here. Okay, component null, that means what is the dialog box that owns this dialog box? Since we're running in command line mode, we'll leave that at null. What options are we going to give the user to select from? All cars is fine. Okay, let's see. I need to catch up with my... Okay, what's the title? Select a car type. Okay, we'll put a string there. What's the message type? Is it going to be an informational message, a question message, a warning message? These are all predefined types on JOption pane, so I can say JOption pane. Okay, and then mine's going to be a question message. So notice I'm going to select the constant called question message. I could make it a plain message, an information message, an error message. All that determines is what icon will appear when this box pops up to the user. So I'll make it question message. Okay, we tab again. Icon, no, that's fine. Selection values, and then initial selection values, I'm going to say car choices 0, which means what's the first thing that's going to pop up in that pop-up box. I did notice an error. I just noticed an error. All cars, what is that argument? 1 second. That shouldn't be all cars. That's the collection of cars that have been created. 1 second. Let me see I'm going to look at the Java doc on that show input dialog because I don't think I did that second right. Oh, message. Oh, okay. Oh, that's easy. Okay. Yeah, that makes sense. So what I'm going to do, this is just the message that appears to the user. So I'm going to change all cars to select a car from the option below. Okay? And now we're going to store this. This is going to be storage. This show input dialog actually returns an object, capital O. So what I'll do is I'll say object obj selected car equals, there we go. I hate that. There's a data type called object. I hate that because it confuses us a lot. So I'm actually not going to use that because it's misleading. Instead, what I'm going to do is something tricky. Hell, no, actually, let's go ahead and keep it. Just don't worry too much about that. I don't like that name. It just confuses people because it's a variable type called object. That's just plain old confusing. So anyway, what I'll do is I'll say string str selected car equals obj selected car dot toString, which will return to us a string representation of what the user selected. And now I can pass that into my create car method. Wow, that's a lot of stuff. So it's about time we go through the debugger as soon as I put a comment here. Okay, show the user a valid list of cars that we can create. Let the user pick one. Okay, wow. So I save, and now I'm going to go up to the main method, and I'll put a breakpoint, and let's watch this step by step, and let's watch what happens. I right-click now, and I choose Debug File. We'll give it a second for the debugger to pick up, and that Pepto-Bismol line will turn green. And there we go. And we know that when the debugger is on a line, we can press F7 to step into a method, or F8 to just execute that method and move on. So I choose F7 to step into the prompt user method, and here we go. F8, 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 just making our selection drop down. F8, F8. Okay, this should show I might have to Alt-Tab to make this visible, but this should show a J-option pane with a drop-down list instead of just plain text. Let me Alt-Tab here. Okay, and there we go. Select a car from the option below, Neon, Cavalier, and Prius. Notice select a car type is the title. Notice we have a label here and a question mark because we said we want this to be a question J-option pane. Okay, and there we have Neon, Cavalier, and Prius. I'll go ahead and choose Neon, and then I'll choose OK. Notice that control goes back to NetBeans, and I can choose F8. Now, this is where the debugger is really handy, because see, I have this variable str selected car. Str selected car contains what? Let me try and move. Whoop, shoot, that really didn't work out well. I was trying to compress. There we go. That's what I want to do. Selected car is neon. You see that? You see we have a string in there in that variable selected car called neon. Hopefully I can, oh, I see I was hitting sort there. You see that's a string with the value neon. So what are we passing to the create car method on line 46? Take a second and look at that and answer for yourself. What are we passing to the create car method on line 46? The answer is we're passing the string neon. So I have two choices here. I can press F8 and just execute this line and move to line 49. Or I can choose F7 and step into the create car method and witness what's going to happen. That's what I want to do. So I choose F7 and here we go. Okay, once again, car type. What is this? We see it's the string neon. We're in this method now and we see it's the string neon. So I choose F8. Is that equal to Cavalier? No. Is it equal to neon? Yes. Okay, so take a look. What are we going to do? We're going to create a new neon object by calling the constructor, and we're going to assign it to this return car variable here. And I choose F8, and there we go. We see that the return car is a neon, because look, the type is neon. The type is neon, and we return that. Okay, now notice my car is a variable of type car, but look, the type here shows what the actual object type is, and that object type is neon. Okay, we go ahead and we prompt, what's the odometer? 10,000. Okay, and F8, 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 we've seen this before. How many gallons of gas? 10. F8, F8, F8. How many miles per gallon? 25. F8, F8. Okay, add it to the collection of cars. And now ask the user, do you wish to add another car? F8, sure. Okay, we start over again. Select one from the list below. This time let's choose Cavalier. The selected car is Cavalier. We go into the create car method. Is Cavalier equal to Cavalier? Yes, it is. This time we're going to create a Cavalier object and return that. So notice that return car, the type now is Cavalier. And now we choose F8, F8, okay. Go ahead, what's our odometer reading? We'll say 20,000. F8, F8, F8. How many gallons of gas? We'll say 20. F8, F8, F8. How many miles per gallon? We'll say 20 as well. F8, F8, F8. Add it to the collection. Now, do we want to enter more cars? Sure, let's go ahead and do one more. And F8, 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 F8. What's this going to be? A Prius, okay. F8. Now F7 on line 46. Okay. String car type. Notice if I mouse over, it says it's a Prius. Notice also down towards the bottom, it gives a value of Prius. Okay, is that equal to Cavalier? The string that's coming in. Is that equal to Cavalier? No. Is it equal to Neon? No. Is it equal to Prius? Yes. So create and return a Prius. Okay, now we're back to the calling method, line 49. Notice that my car, the type is a Prius. So we go ahead, what's the odometer reading? 30,000. F8, F8, F8. How many gallons of gas? 13. F8, F8, F8. How many miles per gallon? 50. F8, F8. Add it to the collection of cars. Do we want to create another one? No, we're good. Okay, F8 returns, and now the green line is on print cars. Once again, I have a decision. I can either choose F8 and let this method execute without my intervention, or I can choose F7, step into the method, and watch what's going to happen. So I'll choose F7. Okay, first we're going to iterate over our neon. Next, we're going to iterate over the Cavalier. Finally, iterate over the Prius, and then we're done. Let's take a look at our output. Okay, there's our neon, there's our Cavalier, and finally there's our Prius, and all the data looks good. So, this is our first lesson in subclassing, and we see that we can give subclasses special attributes and special methods. We also know that for the first time that we've seen it, the variable type and the object assigned to that variable can be different. These are all good quiz question suggestions, by the way. So the variable type can be a superclass of the object type, or it can be the same as the object type. It just can't be a subclass of the object type. Of course, looking at it from the other direction, the object can be the same as the variable type, or the object, which is the thing on the right of the equal sign, the thing where we're calling a constructor. The object can be the same as the variable type, or the object type can be a subclass of the variable type. And the reason is, the variable type tells us what methods we're allowed to call. We are allowed to call any of these methods and attributes on all of these classes because they inherit those attributes. Children inherit from parents. Subclasses inherit from superclasses, just the same. So that's why the variable type can be car, and the object type can be car, neon, Cavalier, or Prius, because these are all guaranteed to have these attributes and methods up here. So we are at almost the 33-minute mark. I'm going to go ahead and save this lecture and upload it. In our next lecture, we're going to take a look at overriding methods, which is actually something we've done all along and we just didn't know about it. So I'll go ahead and stop the debugger, and then we'll start our next lecture, which is overriding methods. Thank you.